Draft physics video presentation, such. Anyway, it's Ken Wheeler video, just for the fun of it, Christmas and such. And alright, the general subject. So he's the king of magnetism, he claims, and somehow photons, I guess, that goes with the camera stuff, I suppose. So, sensibly he argues against wave-particle duality, but he does it in exactly the opposite manner as I would. I would say waves are a trivial consequence, an emergent property. Things wave, things, a group of things can be caused to exchange their condition with each other, and that's called a wave of condition. The condition of dominoes, and that can look like waving, but the individual dominoes aren't waving. So his claim is that there's an ether thing, and that the wave is something that travels through the ether by some kind of domino-like manner. And it's more like dominoes in the sense that somehow you're able to have this wave that's just, a straight line, a ray of wave. So clearly that doesn't really go with the word waves in any traditional sense. We don't have any other examples of, a straight line, one row of dominoes creating a wave in anything else. It's always a medium, and the wave spreads through the medium, and by these rules of the inverse square law and all that. And that's part of where this fails. Well, it's not the inverse square law, it's the 1 over r rule for surface waves. They spread in one direction. They can't spread, obviously, into the air because there's no water up there. But anyway, so you could say, like, ones that are underwater sonar would probably be obeying the inverse square law. So the real question is the big issues, I think, with any discussing gravity or magnetism or light, is separating making the distinction between what's the mechanism, the cause of the motion. And so you have big things. In the case of gravity, Earth and Sun are moving, which are really big things, and there's no apparent source for the energy. The Earth doesn't get smaller, it doesn't burn fuel, doesn't have a rocket engine pushing it. Likewise the Sun. And then magnets, clearly no mechanism for the force that makes them move, in the sense that the magnet doesn't use any energy to move, and so it doesn't have to be accounted for. And then photons get a little trickier because they're not they're the force carrier. They're the thing that's so there's no that's again dissecting the individual dominoes. So you're dissecting it in which way do they how do they move through the atmosphere. And so the argument is this wave-particle duality is the fact that the photons appear to be doing the domino thing, in the sense that they're spreading a wave that can look like that, but they're not spreading. They go to one location. And it's only because of the two slit experiments and other confinement experiments where you use matter to confine light that you create this problem of this apparent spreading, but they don't individually spread. A single photon doesn't actually land in a whole bunch of locations. It lands back in one location. So that's the nature of the wave-particle duality, is that it's if you gave it a random period of time, each time it'll land in a different location, and the location will be an indication. All the locations add together will look like a spread wave of photons, like you shot 1,000 bullets and they all went to different locations. But the truth is the individual photons are just single bullets, and somehow they figure out how to make it look like they waved there when they didn't wave there. Alright, so there's more to this than it's a simple problem, but it's you've got to go through the context of why in my opinion, it has a simple resolution. And yes, it's fundamentally wrong, I think, to say that it's in the very nature that it has duality, that it's actually doing two different things, when I think it is just doing the row of dominoes, and where the dominoes are aligned is what gets changed by the material circumstance. What row of dominoes you're going to knock down is all that's changed. So the photons are very simple, they're just dominoes. So Ken's description of all of this, he doesn't make any account for the energy dilemma. The problem is you have to still have a mechanism to cause this wave. So in magnetism he creates this whole hyperboloid, something's moving throughout the whole magnet, and that motion somehow is converted into this energy release, and that somehow this energy release, this perturbation of force through an ether, somehow compels the other magnet to move towards the magnet excreting this force or lack of force. And but there's no explanation again of where the energy came from, because perpetual energy doesn't seem like something we should fall for. But he does, I guess, imagine that such things do exist in the universe, because how else does he explain where the magnet gets the energy from to move? So I guess that's why they keep looking for perpetual energy and keep claiming, Tesla was on the verge of finding it and all that kind of stuff. Or found it and the government stole it but didn't use it. So you probably draw something eventually, but it's just the context, so I guess I'll draw it first real quick and then get to it, and then we can just then I'll point out where, see, that's the part I'm talking about where he says that, that bit. I believe I'm in the wrong place here. Okay, so not very good, it's a little too dark and all that kind of stuff, but you get the idea. So the problem is that you have two things, two magnets, let's just say, and they're gonna move into each other. Well, as stated, there's no mechanism moving them, so there's no internal energy burnt by either magnet to make them go together. They don't lose any mass, they don't create any force that's known of. So this idea that somehow the magnet's creating some sort of swirly bits doesn't explain how the magnets get pulled together at all. And he concedes some of Maxwell's equations, which are basically, this is the virtual photons that Maxwell's talking about, is this radiation. And the closer you are to the radiation in one direction, lengthwise anyway, you can imagine that something very small in this field next to this something bigger, that if you thought of these all as little tiny point sources radiating, you could see that they would all overlap, and so there would be no inverse square law close in, and it was only till you get far away that the inverse square law kicks in. So in some dimensions with magnetism, you can change the inverse square law to just a 1 over r law, because you're only spreading in one direction, because the other direction has got so much overlap in it that there's no decrease in the force. That's probably a more complex point than I want to make. But the traditional notion of field lines that would be talked about, like that the Maxwell was very good at documenting, their composition, how they get created, has more to do with an idea of a radiating force and just the distance of the, so it's this radiating force that's really defining the strength. So the strength is really the distance, this distance that would be created if you had a standard number of little rays coming out of it. How far apart the rays would be over these different, pi kind of distances would be defining the strength of your force. So it's really based on, this geometry and not so much on this curved geometry. And it just has to do with it always is perpendicular at every point. So even though this looks like a circle or a rounded thing, it's really quite square in terms of the real mathematics of it is kind of a square geometry. Rigidly 90-degree angles and such, even off of the curves. If I said that as quite as brilliantly as I wanted to either. But anyway, so the bottom line, different ways to look at a photon. So yes, conventional science has kind of messed it up because they've turned it into, I don't know what kind of thing, but it's some sort of thing, and somehow they have a frequency, but there's no real description of that thing beyond saying it's some sort of wave, and the wave is, contained in these quantizable bits. So Ken's saying something quite similar. In a sense, he's just saying this coaxial cable idea is just that there's a perturbation, as he says, just a pulse perturbation. I think he actually uses that term, which in a sense, and he says this is very an anti-particle theory, but I mean, technically these perturbations in an ether wouldn't have any, wouldn't fundamentally work any differently than actual bullets. So I mean, it doesn't really make a difference in terms of, I don't think you could see the difference even if you could see it, because what he's describing again isn't a wave in any sense of what we understand as a wave, and so he doesn't really account for any of the quantum mechanical effects, because he doesn't describe how this wave both spreads in some circumstances and remains a solid object when it reaches a destination. So how can it spread, interfere with itself, all this kind of nonsense, and land, exactly as if it was just a straight perturbation. So he doesn't explain how these perturbations interfere with themselves to change the location where they land. So again, my theory is just that this is your wavelength, your frequency of things. There are little things separated by a distance. So a photon is technically, you need two of these things to get a frequency. So it would have to be two of these little bits. And they just move in straight lines, and the only thing that changes how they move is if they hit an electron. The electron will move a little bit funny to a new position, and it'll readmit the photon from that position, and that's where the photon ends up at the wrong place, is because the electron moved funny, and that causes the change. So anyway, so I guess that's a context of some kind. So on to the videotape and such. But he just does this stuff over and over again. I wish he would be more explicit in dealing with the key questions are, where does the energy come from? Where does the energy come from? It's really important. If they're not particles. If they're not, how to say that even, if you're going to claim an ether, then you have to claim that the ether is always pressurized. And again, that doesn't go with this, perturbation things that don't spread. So he's the one with the wave duality problem, because he still hasn't gotten around the fact that we don't have any diagram of a wave that behaves like a laser beam.
Oh, and happy holidays.
Anyway.
Don't celebrate the holidays.
Then why do you bother
the main thing,
saying it?
since humanity's not that evolved intellectually.
You're sort of celebrating it by saying happy holidays. You're sort of, that's the nature of celebrating, is acknowledging it. That's pretty much the nature of celebrating it.
Human beings are still extremely unevolved and intellectually superficial.
Yeah, well, whatever. They're distracted by a lot of psychology that's absolute bullshit, and then somebody tells them a few fables, and they fall for it because they want it to be true. They want the three bears, and they want happily ever after stories, and blah blah blah, and that kind of bullshit. So that's the real, yeah. They're not. I mean, you know, I wish it was as simple as just saying, "Oh, they're all dumb as bricks," but technically, they do know some stuff. Just they don't know the right stuff.
I'll take that as an insult. Well, one of the main things that actually...
Don't take it as an insult, but yes, you're basically insulting your entire audience because they're stupid fools because they can't see what you see. I mean, you know, you're making it quite clear. So I just don't take it as an insult, my insults. Why are they there then? Why use the insults if you don't intend to mean them? If I say everybody's an asshole, I sort of mean it.
misapprehends them is that they will take things which are empirical and repeatable, compositional laws or belief systems, and use those as a supposition for the people that drew those laws up, that they are correct in the explanations thereof. And that's just probably false.
Boy, that was just so clear. So some kind of notion that they're listening to old people's stories, but the story in the real context was they didn't mean that there's actually bears that eat porridge and sit at the table and eat with a spoon. They just meant it like Goldilocks went to somebody's house and they were like bears, and that they were really dirty and hairy people, but they really weren't bears.
For example, Newton's four laws, while they are demonstrably accurate and they are used for computation.
Well, they're all the same actually too. So, but it makes it easier because it's all basically saying the same thing a different way. But yes.
Of far-flung satellites, which are actually maneuvered via UHF and VHF for calculations for very precise orbitals and whatnot, does not mean that the four laws of Sir Isaac Newton were accurate in explanation.
They were simple enough that they almost can't be inaccurate. So to say they're not accurate in as far as they go is kind of silly. It's like me saying you're generally fat. It's a pretty safe thing to say. I mean, there's not much room for me to, I mean, obese, okay, well, maybe, maybe not, maybe you could, well, to me it's pretty safe also. Mortally obese, okay, well, now that's pushing it, maybe, well, maybe not. But I'm just saying, yes, you gotta be a little careful in how you use words.
There are countless, and I've written articles on this, and so has Nikola Tesla, and not articles, but just...
he didn't write anything that's at all useful. That's right, nothing. He had all that extra time when living at the hotel where he wasn't employed, and he still didn't write anything useful.
Tesla's commented. One of the people that actually tore them apart was Walter Russell. People don't understand is that accurate descriptions are
some kind of religious nut as far as I remember, but yes, whatever. Sir Walter Crazy Pants.
in no way, shape, or form connected to the explanations thereof, which are usually given by those same people. There's one thing of absolute certainty, is that nature is incredibly simplex. However, variegation upon a simplex, not simple, but simple.
No, I'd say nature is dumb, because it has no brain, and so it does crazy, stupid things like kill stuff. But, and yes, I would argue that the physics, we could deduce that the physics isn't made of homunculuses. It isn't made of this idea that your brain makes your consciousness, not some little guy inside your brain with a brain. It doesn't brain all the way down. That would be I think a reasonable thing to believe, just looking at the big universe, that the rules do get simple, and it's only in special circumstances where things get at all complicated. But the basic function does appear to be pretty nail-hammer, not computers. There's not computers all the way down. There's hammers and nails all the way down.
Complex laws are not laws except for the nomenclature that humans are so deficient in using and referring to something as a law.
Right, so we could never catch you saying these are laws of physics or something, that you have some rules that you establish. Your pi over psi over die. That's not a rule or a law. This kind of semantics is just, there's so many good ways to attack the lack of imagination lack of disciplined imagination. I don't know what even to say. I mean, you know, it's hard to blame somebody telling preposterous fairy stories that they have a lack of imagination, but it just seems like a lack of grounded imagination, if you want to say. I'm just saying there's lots of good stuff to attack physics for. The idea that they establish things as certain rules of the function of the universe isn't one of them. The fact that they have some laws that they have jumped to a conclusion that it's a law, like light being bent by gravity, that's the foolishness. Little evidence for a law, that's dumb. Lots of evidence for a law, that's smart. Lots of evidence for Newton's laws.
Is that, well, incredibly simplex. They are not simple. We have this notion that we have electricity, magnetism, dielectricity, and gravity, and we're actually trying to come up with a GUT, a grand unified theory. We've come up with absurdities like weak and strong nuclear forces, electromagnetism, and gravity, trying to combine all these things into one simple thing.
Yes, which seems rather a coherent thing to be doing, but they're doing it just horribly because they keep trying to make everything. They find the craziest thing in the group, and they try to make all the other things just as crazy. So they find something that has fairy wings and antennas, and they say, yeah, let's go with that, and let's make everything else have fairy wings and antennas.
And they are fundamentally and always have been one simple thing. There's no such autonomous field modality called gravity.
Or whatever. So again, this is the hyperbole part. Just why bother saying there's no field modality? Or if I changed it to no modality called gravity, there's certainly a function called gravity. So again, this is just semantics. So let's deal with what causes gravity. Now, are you clearly just claiming that gravity is caused because the Earth has a hyperboloid in it? And that doesn't explain anything. Now, if you want to say the ether is full of pressure, and the pressure of the ether, the jello, so let's just call the ether jello, clear, invisible jello. And so the jello perturbations can move through it, things can move through it, it can vibrate and jiggle. And somehow it's pressurized jello, though. It's under pressure. And so you could sort of make this argument that two things get close together, and if you say the jello can't do bent lines, then yeah, clearly the jello would, maybe the pressure would push two things together. Then you're talking like me. But what exactly are you saying? Because an ether by itself doesn't make two things move into each other. Just letting you know. Just saying there's ether out there, dominoes, doesn't make the dominoes push things together. The dominoes have to fall, and a lot of them have to fall to push an Earth. You have to knock over a lot of fucking dominoes, a lot of perturbations.
Gravity is nothing other than incoherent dielectric acceleration, or what the common human fool refers to as magnetic attraction.
Yeah, so it's, gravity's magnetic. Okay, there's absolutely no evidence of the strong magnetism strong enough to move to the Earth, the heavy, huge, giant mass. You can barely move a little tiny needle with the magnetism created by the Earth. So, I don't know, you're saying we're all idiots because we didn't fall for the completely empty bag of evidence you have. You have absolutely nothing to offer as evidence of how obvious this is that it's magnetism, when there's no obvious evidence. There's no evidence at all that magnetism is why space shuttles need big rockets.
The only distinction and differentiation thereof is one of attribution of quality specifically. Since magnetism is coherent, it is therefore multiplicatively more powerful.
So again, the fact that this magnetism is coherent, which I guess just means it's somehow in phase, and it somehow doesn't spread, or something like that. It has these new set of rules about how it moves through the jello, that somehow that explains how the jello pushes us onto the Earth. And I don't see that as an explanation. I can't, again, you're just showing up like some kind of Santa Claus with some bag. I have an infinite number of stuff and I can do magic, and I'm supposed to, you're wanting me, just pay me $10. No, I'm not paying you till I actually see you produce something out of that bag.
Rather than incoherency. The only thing that actually defines a magnet, for example, in humanity, if you actually do a Google search or go to any of the largest manufacturers of magnets and go to their frequently.
So he said this so many times, like somehow this is an argument that his theory is right, is because they don't give you a technical details either. So to me, it's a valid argument against the conventional science is to say, why don't you have any details? Why do you have to use some kind of virtual stuff to explain what's happening? And then even when you have virtual stuff, you really don't explain how the virtual stuff does this magic of forcing everything to move. So yes, their explanation is weak, but you're not providing something in its place that's any stronger. You don't have any explanations either. You just say wave in what, where somebody can argue ether of what.
The ask page is what is a magnet.
I mean, we know what waves travel through. Water waves are traveling through molecules. We know there's a mechanism, a medium, and so you're just saying there's some magic medium that somehow knows where the dominoes are supposed to be, and you don't explain how it knows that.
And how does it work? And they'll tell you flat out that they don't know. I own every book ever written on the topic of magnetism, and all of them are complete absurdities.
Yes, I don't think most of them go into any details at all. So it's all just this Maxwell stuff, which is really good. I mean, the fact that it's been they've diagnosed the relationships and the strength of the magnetism and that kind of stuff through experiments. So at least they know the confines. They know what a description of the cause has to be in, what kind of box it has to be in. And you're not talking inside that box. And so in a sense, you violate the part they do have right.
Quantifications, and they will try to reify action at a distance, which is one thing that physics, and of course therein lies the defect, one of many defects, is that since fields are not physical, they cannot reify interactions at a field level, because they will use one of several incoherent, anti-intellectual, stupefying absurdities, such as virtual particles, if you actually type.
Right, so that's right. So yes, they cheat, but again, you cheat. So you can't really call them on the very same cheats that you're using, in the sense that you don't really explain a mechanism. Saying hyperboloid, saying whatever the other one is, doesn't explain how the atoms inside of the thing, well, you don't believe in atoms, but whatever the matter is moved, because we know that for a space shuttle to move, you got to put big rockets on it. So where does the energy come from?
In virtual particles on Google, you will actually see that these idiots, these supreme so-called and presumed idiots and masters of science and physics, believe that interactions at the field levels.
We should come up with a better word. I mean, it sounds nice to call them idiots because they seem to be idiotic and all that kind of crap. So I'm sort of agreeable to that. But I think we should just call them jerks, because they're not stupid. But I mean, this part where they can't figure out, if my theory looks like a religion and it quacks like a religion and it walks like a religion, then it's a religion. They can't even do that. That is pretty idiotic. So it is, jerk, idiot. Alright, toss up. It's a duality. The idiot-jerk duality. They have qualities of both.
Just magnetism, or ultimately particles. They will call them virtual particles, even though those have never been the input or output of any experiment.
Yes, again, I don't know why you're making this complaint, because they never use the word particle as it's a real particle. They don't believe in particles. The entire physics is built on the assumption that none of it has any place, and it's all ambiguous, and the photon, the electron, the atoms themselves don't even have a spatial time dimension. They're all floating around in blah blah blah. And so they've already destroyed. When they say particle physics, they don't mean it, because they've given these things non-particle properties. So they shouldn't be allowed to use that word. They should have to use the word wavicle or something, some other word to point out how they don't mean discrete thing in a discrete location.
Ever done. They will presume that Mother Nature is a crazy cross-eyed hooker on crack shooting heroin that's
So he just keeps doing this thing that somehow their wacky theory isn't as wacky as his wacky theory. That it doesn't just as much fairy dust and leprechauns. So I don't think you've made anything simplex or simpler, or you haven't described a simpler function. Perpetual hyperboloids is not a simpler function. And like I said, I might even go for it if you in some way explain how that makes two things repel or two things attract, but you don't even do that. You just say there's the energy. It's all this figurating hyperboloiding going on in the magnet all the time, and somehow that magical force, that magical movement, causes repulsion and attraction. By what mechanism? How does the Jello know?
Paradoxes and dualities exist in nature, and the one thing to be certain of is that
yes, duality is a tricky word, and yeah, it's just there's only a duality in the sense that it's like this idea of trains on tracks. Okay, trains ride on tracks, and then there's this duality thing where sometimes trains end up going down the road and plowing into your house. Now, the duality could be understood that well, trains run on tracks until they hit the broken piece of track, or the water buffalo that went to sleep on the track, and then they're not on the tracks anymore. Now, that would be a context of the statement. So you could say, if you're totally ignorant of the fact that sometimes train tracks don't work, or sometimes the wheels on trains break, if you didn't know that, you'd say, well, there's a track-road duality. But there really isn't if you analyze the whole circumstance. There's no duality at all. There's specific circumstances where, yes, trains become cars, but they didn't do it for no reason. And they didn't do it as one of their fundamental functions. They did it because the track's broken.
Any intellectually evolved human being that understands the most fundamental natures of cosmic mechanics is that nature.
Right, so we all were born with this knowledge of cosmic mechanics, and this isn't at all a little bit of a complex subject, and so he's just going to insult everybody's intelligence who somehow wasn't born with some sort of innate knowledge of how the universe should work. Oy. No, I'd say it's okay to ridicule people who've spent their life, analyzing the subject, and they haven't run across the fact that, hey, you know what? This is all based on very little evidence. Maybe we should slow down a little bit because our train's going to go off the fucking track.
At its most fundamental level, and even above that, has never, and will never deal in paradoxes or dualities. Three of the most famous words, and of course, much of quantum.
Well, again, see, I just, all your rhetoric is just so excessive. Clearly, there's no fundamental paradox. But clearly there can be one from our point of view, in that we don't get to see all the details. So there certainly could be an observable paradox in the sense that our observations, like with the train analogy, are incomplete. So we could see 2 microbes go in and then 3 microbes come out, or something like that. And we could draw some duality thingy or something. They went in red and they came out black or something. So we can draw conclusions, but we don't have the detail. So that's the duality, or the paradox is just made out of the fact that for the time being we have to use that word because we don't have enough information to clarify what exactly causes the phenomenon that is disturbing the logical sequence.
And by the way, quantum is a completely absurd term which has actually no basis in reality and refers to that.
No basis in reality for a word that basically means something like the discrete or the smallest, or it's related to those kind of concepts. So clearly it has a history, and clearly I think it has an appropriate use in physics. So I don't think the word quantum really meant shiny shoe. So I think its origin is reasonably close enough to its current use, which is smallest quantity, or it's another word for, like atom has already been used, so it's another way of creating a new atom word where we mean it this time. Planckness. I mean, Planckness would be a nice thing. Okay, give a little credit to the guy, but we could use some other vernacular. But quantum works as a way of saying the universe is based on these little things that don't get littler, and they have rigid probabilistic rules about how they move.
Any type of science show that you watch today, the word quantum is used as a filler word, and here's the actual explanation of the word.
I would agree that they use the word too much. They use the word to disguise something they really mean nano. They're talking about just small things, but not necessarily the smallest thing. And so they cheat because quantum sounds mysterious. And again, it is in the sense that we don't have a real solid definition. I like the word personally, so I'll tend to use it to describe these little bits. But clearly in quantum mechanics and physics, quantum often in their brain is much like what you're thinking of, coaxial cables and all kinds of complexity and waves in different mediums, and they'll call that a quantum. And to me, that's just making the same mistake they did with the atom thing. You're just not getting to the root of it.
Quantum for you. Anytime a scientist or some BS science fiction movie that you watch, they'll use the word quantum as a placeholder in a sentence to describe something that which they have no understanding thereof. Back in the day when...
So that, I don't think there's not no understanding. They have a misunderstanding. I would agree with you on many of the times. And some of the times they don't. Some of the times they get it right that photons are little small things, and they do quantum-y things because they're very small, so that makes sense. But yes, when they start saying big things are doing quantum-y things, yes, then they're off the track.
Human beings didn't understand stuff that was going on in nature. It would say, well, leprechauns did it, or that was fairies or ghosts, or...
Yes, goblins and pixies and... they use a lot, those things that made movies, gremlins. Gremlins, that's a neat idea, the little gremlins. They're like homunculuses, evil homunculuses.
We would actually come up with all sorts of insane hyperbolic BS as unevolved anti...
Yes, right, and again, what have you done that's not exactly that? That's just big fat hyperbole. Hyperberloid. You can't. The word even has hyperbole in it. I mean, it has. It's a hyperbole in itself. It's self-describing itself as a fucking bullshit explanation.
Intellectual, pathetic creatures that human beings still are to explain the nature of cosmic mechanics. Quantum is...
Well, look, we have discovered lots of stuff. People have done lots of good science. There's a lot of bad theory. Good science, bad theory, something like that. So, but you can't throw it all in one bucket and say it all sucked, because it didn't all suck. Just some of it sucks.
Another word for unicorn and leprechaun. Quantum. It is really funny if you actually have evolved sensibility.
So they really do basically say right to your face, just do the math. Yeah, we don't know why. It's weird. It's fucked up, but it works. So blah blah blah. So they actually say it to your face exactly what they're doing, and then you claim they're doing something else, like they're offering you a full explanation. They're basically saying, no, we don't want to give you a full explanation. We don't even care about full explanations because we think somehow knowing the mathematical relationships is all we need to know, and that's sufficient to do everything we need to do that's important. So we'll just forget about what kind of radiation comes out of magnets. As long as we know what the strength of the radiation is at particular points, who cares? I mean, I think that's stupid, but to say that they're claiming to know, I don't think they're claiming to know. Now, when it comes to the whole universe, yeah, they're making lots of claims that they somehow know, how black holes do how they do square dancing, how they do everything. They seem to know way too much about the fucking black holes.
An evolved intellect, and I know that sounds hyperbolic and egotistical, but I do have...
Yes, everything about your persona is excessive and egotistical. So if we just replace hyperbolic with excessive, exaggerated, everything about you is exaggerated. We went too far. Too much tattoo, too much fat, too much bald. Yeah, you went too far with everything. You do go too far, too excessive, and what's the other word you used? Jerky. Yes, and you're a jerk.
is that if you actually listen to scientists talk about something, so this is a quantum effect, or this is quantum cascade, or it is a quantum so-and-so, it's a quantum. It's not...
Yes, well, that's usually when they're using quantum in the terms of the probability concept. So, and that's, like, again, you're just stuck with their non-explanation for the duality of the end result. So they use waves to get there, and they always get on a surfboard and ride the waves and then land on their surfboard.
Other than a pathetic word to describe something that cannot be defined by them nor explained, specifically the reasoning for that is that fields are not particles, and they certainly are not waves.
Yes, but a field of particles is particles. So again, it's really easy to fix their jargon by just replacing their words with another word and just say, yes, a field of particles works. So if you made it a field of particles, if I made the ether out of a field of particles, how would it function different than your ether? If I made the ocean out of little beads, okay, and I gave those beads clinging properties, that they were a little bit sticky with each other, I could create something that worked just like the ocean. It would move just like waves on the ocean. Everything would be exactly the same. So, you know, no point in yes, there's a point in saying what they've done is wrong. But again, if you're not going to make it clear, you're just going to make it more complicated, you're not doing the right thing either.
And there are waves, anything in of themselves. They'll often actually refer to fields as wave interactions, or refer to one of four Maxwellian field equations, which have never defined a field, rather only field interactions in exposition as a resultant of a vector over a period of time with a known result. They can be quantified.
So again, a vector, and it is quantified. That's the whole point. So, but yes, that's the thing to understand about Maxwell. I mean, he wanted there to be an ether. He couldn't find one, so he didn't cheat and force it into his equations. And the wave property is just a bunch of little things, okay, that create an effect, but they're still discrete bits. They're things moving in a vector. I mean, Maxwell's equations, he never used the term virtual photon, I don't think, but that's what it is.
It's quantifiable so far as effect, like as measured in force, joules, megawatts, or voltage, or amperage. Or Maxwellian field.
Yes, right. All that stuff comes down to stuff, quantities of things, little bits like a photon, and it all adds up when you add all that stuff up to a quantity of motion. And that's what energy is. And so you have to if something piece of matter moves, you can find out why it moves, because it had to collect the movement. It had to collect it. It didn't just move.
Equations have never defined a field. But human beings in their intellectual inferiority will ascribe paradoxes and dualities to nature that cannot be ascribed there too. Three of my most favorite words that I hear quite often.
So I don't know. I don't see anybody ascribing paradoxes. Basically, they're ignoring the paradoxes. So I know that you didn't even get that argument correct. The problem with physics is it's ignoring the paradoxes it's creating. It's ignoring the parts that don't fit. The fact that they're having to really hammer the puzzle pieces into place, and they're in there with their hammer, and they're not even realizing, wait a minute, this isn't how you're supposed to put puzzles together. You're not supposed to be hammering these things together with dark energy and dark matter and all kinds of dual universe and, you know, paradoxical wave particle functions, and they're not supposed to be forcing things like that. That's not good puzzle putting together.
Specifically, since much of quantum mechanics and field theory by stupid human beings or intellectually unevolved human beings, which is 99.999% of them, is
intellectually unevolved. So again, intelligence evolves, and clearly our intelligence on planet Earth and knowledge has evolved. We know what microbes are, we know lots of things, so it's just stupid to say we haven't acquired information. Now, the fact that we're not processing the information very well, that I'd say yes. We haven't even figured out that dying sucks and lots of other stuff, so yes. The human race is dumb as a stick when it comes to most of the really important shit. And the only stuff they seem to get right is dressing Barbie or something. She always looks very stylish. But yeah, everything else they can't figure out how to do right.
Stuff like wave particle duality. if we actually examine that little phrase, which always occurs together in a three-word lump, wave-particle duality, let's talk about the double-slit experiment. In wave-particle duality of light, all you have to do is just type in parentheses in a Google search, wave-particle duality. Three of my favorite words because it's exactly like saying...
So what he's saying is there's no particle part, there's just waves. And then again he says, waves of what? And then you say, yes, waves in what? I'm saying that to you. Waves how? How do waves push the Earth into the sun?
You know, flying, levitating unicorns, or glowing leprechauns on magic carpets. You see, let's actually examine this thing, because wave-particle duality is always a phrase applied to the paradoxical nature of light.
No, it's applied to the fact that there's conflicting evidence. There's actual evidence, okay, that it moves like a single string of dominoes. And then there's evidence, though, that somehow where the dominoes are pointing is duplicating spreading of waves. Yeah. The evidence is thin. Okay? It looks like the same kind of on-off pattern. So the simplest pattern in the universe, they've decided it's interference because that's what interference patterns look like, and they haven't realized that, wait a minute, it's the simplest pattern you could possibly create. Sure, other things could create the same pattern. Yes, that would make sense, that other things could do it besides a wave, interfering with a wave.
Let's first start off by stating what I've already said and emphasize it emphatically, is that Mother Nature nor cosmic mechanics deals in paradoxes nor dualities. It's absolutely impossible. Nature has no paradoxes and it has no dualities. The only paradoxes do.
And again, I don't think anybody's arguing that it's good that they're saying this shit, okay? They probably would be able to like to say it's one thing, a wavicle, or, you know, like you, they'd like to be able to just say it's a coaxial cable and leave it at that, okay? They'd like to be able to say something silly and get it over with. But those explanations aren't good enough. I mean, you're holding them to a standard you don't hold yourself to. You really think it's good enough. If I just said to you, well, light's you know, it's dominoes going in a straight line, and where the dominoes straight lines point is because of a coaxial cable-y thing that the dominoes are in, and that's a good enough explanation. And because the hyperboloid is what told the dominoes which way they should point, and you're not giving any, you're not making this simple. There's nothing to your explanation is worse than theirs.
Realities exist within the unevolved minds of pathetic, stupid human individuals, which is all.
Yes, well, I'm just saying you're being pathetically undetailed and undescriptive for somebody who's going to complain about other people's descriptions having a bunch of, well, we'll just rub that part out and just have a blob there. So it's not really a number, okay? It's sort of, yes, there should be a number there, but man, we'll just make it blurry for now because we don't know what the numbers should be.
Well, humanity, so don't take that personally. Wave-particle duality, let's actually...
I think they should take it personally, and frankly, I wish you meant it. It's just that simple, yes. I would argue that, yes, most of the people listening to me right now have so many dumb, wacky, idiotic notions in their head that they can't see through all the bullshit. Yes, the world is simple, but the bullshit makes it impossible to be seen. There's so much shit on their screen. You know, their windshield is so fucking dirty with idiotic notions of, you know, little dead bugs of bullshit that, yeah, they can't see anything.
Cross-examine that, since this is always used in reference to light itself, but human beings have absolutely no idea what light is.
And so he does, the superhuman. And his idea is it's a coaxial cable, electrically and magnetically something or othering in a perturbation mode. Well, that's great, thanks. That says so much.
They have no idea what light is. Light is not what something is, nor is it a principle, nor is it a noun. A wave is what something does. When people talk about waves,
So again, it's just not true because everything that does wave is waving in a medium, which means the medium is moving in specific and detailed ways that, are just a fact. So it's a phenomenon of what many things do, never really a phenomenon of what a single thing does. Just kind of the truth.
What you have to do to shut them the hell up is say a wave of what? Well, a wave is an electromagnetic wave of what?
So the very thing he uses, which is the electric field and the magnetic field, somehow the ether fields, he uses that same jargon. I mean, that same bullshit is in his theory, and yet he's saying a wave and what? Sorry, you're not explaining the distinction any better than they are. And certainly there are physicists who believe in these field theories, so they believe there's a field for every particle. And what's your big difference? You say it's all one field with two modalities. Yeah. I mean, what is that? How is that an improvement in the description? It's dominoes going this way and dominoes going this way. Yeah. They can't go three ways.
Well, electromagnetic waves, we're talking about light here. Transverse coaxial. Electromagnetic, okay, wave of what again?
Yes, transverse coaxial. So he said it like he was mocking it, and that's his own theory. So I guess that was what you call a Freudian slip or something.
Well, these are electromagnetic waves. You see, you actually get into this self-negating paradox. We'll talk about EM waves. So, well, it's electrical, but it's a wave. It's an electrical wave. A wave of what? A wave is not a thing. So the electricity doesn't exist unless it's waving. What is the electricity?
Yes, so they say it's a field, the electric field, which isn't any different than you saying an ether field. So what the fuck is the difference? How exactly is your theory different than their theory? They're claiming it's a perturbation through a field, just like you are. A field of what? Ether. That's the explanation. Oh, Joe, that surely did explain everything. Right, it's a field of ether. Okay. Jello. Pudding. Invisible.
Electricity, it cannot be quantified. Well, sure, we can quantify electricity as joules or voltage. Polarization, circular polarization, transverse. Yeah, no, we've still not defined what it is. By the way, electricity is phi times psi equals q and Planck electrification.
Yes.
Electricity is an autonomous field modality. It doesn't exist.
So there's no rules except the phi times psi times whatever he said. Like that's supposed to mean something. So he's talking about people being idiots, and yet he says something that absolutely no one who doesn't know his special language could know what the fuck he's talking about. So, but somehow that's evidence, and they fall for it. So that's all that matters. I mean, the guy is pragmatic in the sense that he knows they don't want any more information. They don't need any information. They will glorify me and rub my nipples, and all I have to do is say hyperboloid, and they'll go for it. And Tesla's name. As long as I keep saying Tesla's name over and over again, they'll fall for it.
Electricity is actually a hybrid of electricity and dielectricity. If you actually understand,
electricity is a hybrid of the thing that it is plus the thing that it isn't. Oh, okay. That explains a lot too. No, it doesn't. Flour is flour mixed with some, maybe not flour.
Axial nature of light, which is a longitudinal pulse perturbation dielectric.
Longitudinal pulse perturbation. So again, he's just saying exactly like a baseball flying through the air. It's a pulse perturbation. It's a thing moving through something else. The non-baseball field, and the baseball is going through the non-baseball field. Same exact thing as a practical matter. Hasn't elevated the conversation, hasn't given more detail than me just saying that. A perturbation is a change. Baseball, you could say, is a change. Change moves through the air. What's the difference? Nothing.
And a transverse electrical magnetic, we're actually talking about a trifold circuit.
A trifold circuit. I mean, like that's supposed to mean something. A trifold circuit. Somebody's supposed to know what the fuck that is. A trifold. I'm supposed to be able to draw the trifold circuit. That is a coaxial trifold. So it's a 2 thing with a 3 thing. How does anybody tolerate this as explanation of anything? This arrogance. This obnoxious arrogance. All this ridicule for everybody else being a fucking imbecile, and he offers that kind of rubbish. And then he complains about other people having pixies in their theory, and and gremlins and hobgoblins when what the hell is this shit? A trifold.
This is a field perturbation which propagates.
A field perturbation, right, which is exactly what they're calling a virtual photon. No different. It's a disturbance in a field or a thing in a field. Same thing. The baseball is a disturbance in the air. What's the difference?
It doesn't move, but it's a rate of induction of the ether itself.
It doesn't move, but it's a rate of induction. But it doesn't move itself. But obviously it does move, because the induction goes from one thing to another thing at the speed of light. It doesn't go by some other speed. So how do you get away with that nonsense?
It's like a disturbance in the water. Waves in the water don't actually move. Of course, we are talking about waves, but not waves themselves.
Yes, right. We're talking about the pressure. The pressure does move from the point of origin to a location by a specific speed that's much slower than the speed of light, because it's a thicker medium than the ether. But clearly it moves. The disturbance moves from one location to another location. No doubt about that. It doesn't get there spontaneously. I mean, instantaneously.
Also about waves of water, and the water doesn't propagate in linear fashion. One wave...
Yes, it does. So again, it's just stupid. The waves are moving. It's just stupid to say that's not what it's doing. The pressure moves. The high pressure moves. The wave moves. Moves. Moves.
Which causes a disturbance in the next group of water or hydrous oxide, however you're specifically going to get.
Hydrous oxide, I'll say it again, is wrong. Okay, it's just not right to say hydrous oxide. Wait a minute. Yes, it's the other way around. H2O. There's not two oxygens. There's two hydrogens. So it's oxygen hydroside. Yeah.
And we actually have a disturbance which actually goes like this, but waves don't propagate in linear fashion. Neither does light move, but that's a matter for another discussion which I've delineated beforehand months ago.
Well, whatever. It does move. It's just stupid to say it doesn't move. The fact is that the fact that it creates a high and a low means that it doesn't go back to a neutral, because everything has to keep responding to the change. So the fact that the waves keep coming is the thing that fools us. But if the medium wasn't vibrating so much, if there wasn't so much tension in it, then the wave would just move as one wave, and then you'd have no doubt that, oh yes, it's a wave moving. I get that.
Ago and countless other videos. But let's get back again to the wave-particle duality.
I mean, what I'm trying to get to is that when in thick mediums, what happens when something creates a pressure, it keeps bouncing. So it keeps at the origin. So the origin keeps creating new waves. And that's what keeps fooling us into thinking, well, it's just high-low. No, it's really just pressure. And then there's another wave of pressure, and then another wave of pressure. They're all new waves of pressure. They're all new pieces of pressure because this keeps happening at the origin.
As always in reference, used by pseudoscience, i.e. current modern science in reference to light. So we've eliminated out waves, since waves are never a reference to anything specific but what something does. A wave is not a thing, but what something actually does.
So again, it really isn't the truth. So fine, but I mean, there's the reason why the word wave is just not applicable is because of the fact that waves are in mediums and they spread. Photons, individual photons, don't spread.
Light is certainly not a particle. The notion of a photon is an arbitrary concept with no basis.
Okay, so again, this idea that's arbitrary when, no, there's a ton of experiments that indicate that it's this discrete bit of stuff, a discrete amount of energy that this wave carries, and that it is in these quantities that can't be broken smaller, and it has lots of things that indicate, you know, it's not a wave, because waves can be really tiny, and this stuff can't be. It's all one, it's one amount, and then it's two amounts, then it's three amounts. It's never 1.5 amounts of photon. So again, arbitrary is an idiotic word to describe something that you acquire based on a ton of observed evidence.
Basis in reality whatsoever. The notion of the photon came about by...
No basis in reality for us to understand that this thing is different than the other things. It has properties that are very different than other stuff. That light is something different than glass or cigarette. Yes, it's very different.
Misapprehensions and miscomprehensions of the nature of that coaxial, specifically the longitudinal pulse perturbation. E equals nu v, energy equals frequency.
So I understand, he's just talking about a little blob, little perturbation. And then he has some sort of notion, he hasn't explained yet, how he has some understanding about how that pulse perturbation hits the two slits and does this wave math to end up which way it's going to go. What's his explanation for how that takes place? How this single perturbation of a photon all of a sudden isn't a single photon anymore. I haven't seen him provide anything called an alternative explanation.
T times Planck's constant, where we actually have a higher frequency of light, for example.
So again, this is now back to this idea that somehow the light has more energy because it has a tighter frequency. And as I've explained, a simple, just quite obvious explanation for the difference in the energy in terms of what we see happen to things hit with different kinds of light is the tipping point argument. That you hit something with bullets really slowly and it'll just wobble, but if you hit them at the right harmonic, you knock the thing over, the tipping point. And so, yes, higher frequency things can cause the subatomic structure to degrade easier because it's the tipping point. It hits before the thing can rebound, and therefore it knocks it over. It creates an effect that the slower hitting light can't cause the same effect because the frequency's too low. The thing rebounds, and once it rebounds, you can't knock it over.
And they're what, bigger photons? Actually, the more...
Yeah, so he laughs at a straw man argument because obviously they don't think there's bigger photons. That's the whole point of the quantum thing again. So there is the Planck thing is basically establishing there's no bigger. There's just multiples. You can just add more photons, but you can't make bigger photons or smaller photons. So he's straw manning the argument and then laughing at his straw man. So another really pitiful bit of behavior.
Smaller, since we're talking about capacitance, the smaller the space, the higher the capacitance. The actual higher frequency, the more powerful the light is, it actually has a smaller spatial footprint.
Yes, again, nothing, just not really a rational explanation. A smaller thing is more powerful. It's just a rule. See, he's established this as a rule of some kind. There's more capacitance in smaller. When you could argue that closer means more pressure, I would go for that. But it can't mean anything else. And as I pointed out, the real argument is the only thing that makes frequencies have different effects is the circumstance of what they're hitting, not the circumstance of the frequency. There's no more energy in the ultraviolet light unless you're measuring it as a distance and you're saying this much ultraviolet light. Well, this much ultraviolet light has more perturbations in it than this much infrared light. So if there's a timed equation, yes, the ultraviolet light will have more bullets in it, but the bullets themselves are not more powerful.
It's a transverse electrical magnetic. So the smaller the light is, both specifically and technically, the more powerful it is. And this, of course, is completely aligned with the fact that the smaller the space, the higher the capacitance.
So again, this idea of capacitance in just some generic sense, like everything has it, when they don't all have it. There's actually less pressure between electrons and protons when they're closer together. Pressure is some phenomenon that has specific modalities, specific circumstances that create it. It isn't created by anything.
And of course, science has never explained that. They've never explained how a much smaller spatial vector has a much higher capacitance. I can't.
Yes, they don't really create an explanation because they don't really go into more mechanical details. So they don't give us either a particle or a wave description of the increase in the energy. They just make it as a rule and establish it, that's the effect. But they don't look inside the box. So they create a box that says this goes in and more stuff comes out, therefore this is responsible for more. When the reason why this was responsible for more did have a circumstance. There's a reason the train went off the track.
And it's extremely logical and very easy if you actually understand what the hell that is. So we actually have wave.
I would agree. It is very easy and simple to understand if you just make the light what it obviously looks like. In most 90% of the 99% of the experiments will show you that it's a little quanta, little BBs flying. It fits perfectly with that explanation, and just recognize that that's its property. It's just little bits at a frequency. It's little baseballs moving at a frequency at a constant speed, always constant size baseballs moving at a constant speed, and the only thing that makes one form of it different from another form of it is how far apart the baseballs are. Works perfectly as a model.
Particle, we've eliminated out those two since light is not a wave, because a wave is not a thing, and it sure as hell is not a particle. If you think that light is a particle, you are deluded and brainwashed, and it's much a pathetic.
Right, so he's saying it's not a wave, so he's, I don't know, he's conceding a point of some sort, but he's saying it's a perturbation, which is the same thing as a wave. Like I said, if I had a medium that didn't keep rebounding, water would create an obvious wave. One wave would move right across the surface, and you wouldn't be fooled into saying it's not moving as a wave, as a pressure, because it's moving pressure, quite obviously.
Atomist, as the rest of modern physics. You see, physics by definition is about physical things, and herein lies the rub. We're talking about atomism.
Yes, and I don't see how you're doing any physics here either. So I don't know what the baseballs aren't baseballs, they're perturbations, and that's a huge. He's saying that's a huge advance. So to just say that this is made out of nothing and it's in a field of something, so I could just reverse the whole universe and just say this is actually nothing and it's in a field of something. Have I advanced science in some way by just turning it all, just changing the colors, making all the black things white and all the white things black? I've done the world a favor? I don't think so.
Atomism, of course, has no connection to field theory. No connection at all.
Alright, to ether theory is what he means. Okay, it has no connection to, we're going to make all the solid stuff the force stuff, and we're going to make all the material stuff all the force stuff the material stuff. So the forces are the ether, the material, and the material is the non-ether, anti-material.
Duality. Well, not only is light not a duality nor a paradox, but the very notion that humanity, i.e.
It remains a paradox. So I agree that duality is a non-answer, so yes, let's throw that out because it's not an answer. So you just say, I don't know, or something. But the fact that there exists a paradox in the evidence, in the sense that there's conflicting evidence, I would argue that the conflicting evidence is easily resolved with a little bit of imagination, but regardless, it exists as a paradox, in the sense that we haven't answered the question yet. And so if we use the word paradox to mean something we don't have an answer for, yes, the paradox exists. It's a problem with the model. There's no paradoxes in the absolute model, the real world. There's paradoxes in our model in the sense that our model does something that is conflicting and therefore needs resolution.
Unevolved, unintelligent part, which is basically 100%, would think that Mother Nature or cosmic mechanics would deal cards paradoxically, or deal in dualities.
So again, this is just a straw man argument, because I don't think even the physicists that argue this are perfectly comfortable with the fact that this exists this way, that we don't have higher resolution. And I don't think most of them think this is a satisfactory answer, besides the pragmatic effect of saying just do the math, which is just saying I don't want to do physics anymore, I want to do math. So instead of being physicists, they're being mathematicians. So they ought to just retitle themselves or get in a different discipline, but they're not doing physics anymore, they're just doing math, and math isn't physics. I mean, it's a help in making models of physics, It's like glue isn't Legos. You know, I mean, glue Legos, but, you know, glue isn't Legos.
Duality, by definition, is stating something that is misunderstood or misapprehended. Nothing in and of itself is ever a duality. We actually dissect the word both in connotation.
Well, I don't know if that's even, you know, I don't know if you can say things can't have dual purpose. Of course they can. So things can have, you know, multi-purposes. A screwdriver can be a murder weapon, you know, it can be a dual purpose. So you got to be a little careful going too far with this thing. I mean, obviously in an explanation of a model, giving things two functions at the same time would be very dangerous. So obviously we've made it possible that it has two functions because we've spread the time equation open, and we said we can't do the time thing, so we can have duality because two things can actually be happening in that period of time that we've left open.
Denotation. There's nothing in Mother Nature nor in cosmic mechanics that can be or ever could be a duality. Well, it's both particle and wave at the same time. No, it's neither particle nor is it a wave, because a wave is not a thing and it sure as hell is not a particle.
Alright, so he's you know, as much as he keeps talking in wave theory, he doesn't believe in waves apparently. So I guess I learned something new. I thought he was comfortable with the word wave, he just didn't like the word particle. But apparently he doesn't like either one, which is really weird.
Humanity has never understood light. It's neither a particle nor is it a wave. Here you're talking about a duality of whether it's a particle.
Okay, so good. So you're saying that this perturbation thing at a frequency doesn't have a wave character. And look, it's an unfortunate part of language, so I will be perfectly happy if everybody would agree not to use the word wave for things that have discrete functions, you know, that aren't spreading. I mean, it would be a nice rule to have that you can't call it a wave if it doesn't spread. Like a laser beam couldn't be a wave of light, you know, because yeah, it's not spreading enough to be a wave.
Or wave, it's kind of one and it's kind of the other, therefore it's both and neither. That is the most unevolved, unintelligent statement said by stupid human beings, and human beings are really, really goddamn stupid! Stupid! Extremely stupid creatures. So,
yes, whatever. You haven't proven them, but you have proven yourself to be deserving of a category of reckless, sloppy, exaggeration. It's just that you're just as big a fairy storyteller. The coaxial cable bullshit.
My three favorite words that I see all the time, as always used in connection with the word light, is wave-particle duality, because every time I hear that, my sphincter puckers, and at the same time I laugh my ass off, because humanity is so stupid. Now, before you call me an egotist, I would like...
No, that doesn't even say it, really, yes. I'm not going to call you that, because you're psychotically egotistical. You're in a category that's so far out of the acceptable realm of just an ego problem. You've got trifold ego mania.
You think and pontificate upon those three words. Then you have to have a deeper understanding of field theory, but you also have to have a deeper comprehension of the nature of light. But the notion of saying that...
And the one you can't explain. So you do hours of these videos, I mean, totaling up just hours and hours and hours of talking where you just keep saying the same thing that doesn't provide any details at all. And then you claim you're all idiots because you don't understand what I'm saying. Well, you're not saying anything.
In any sort of wave-particle duality is both amusing, pathetic, disgusting, disturbing, and a gigantic gravestone marker upon the unintelligence of humanity. Waves.
Gravestone marker upon the unintelligence of humanity. Look, all us humans aren't guilty in the first place. No, we'll not do that. We'll finish this up.
Light, excuse me, is neither a wave, nor is it a particle, and it sure as hell is not a duality. Wave-particle duality always is said in connection to light. This is how unevolved...
I thought he believed in waves because he was constantly saying a wave in what, so I thought he wanted people to say ether. So he apparently doesn't believe that this perturbation thing is the same thing as a wave.
Unintelligent humanity remains regarding field theory. Very, very unevolved. Very unevolved. Lux Divinitas, thank you so much for watching. If you like these videos, you can always click the link below. I will get a full explanation of light in my future book. which I'm fully working on. And
right, and the past book was supposed to be a full explanation of magnetism, which explains absolutely nothing. Zero edification is what you're guaranteed, unless you know what a hyperboloid does, and you know how hyperboloids cause other things to move. It's not of any value.
Not an easy thing to describe or illuminate to people. Haha, joke intended. Thank you so much for watching, and happy holidays. Bye.
Well, you did it again. You celebrated the holiday. Stop doing that. Anyway, so, whatever. It'd be interesting if these people had any will to defend their theory, and again, I will defend mine to anyone willing to make even a slightly reasonable argument. Just be slightly polite, you don't even have to be a little polite, even less than a little polite, and I'll tolerate it, because it needs to get done. I mean, there needs to be some sort of back and forth here where this shit is argued, because this idea of people just saying crap that they don't have to defend, and nobody gets to say, what the fuck is that? What do you mean? Explain. Nobody gets to say explain? Come on. It's not right at all. Anyway, till the next time and such, so forth and whatnot. Sorry, this, a little bit technical issues. I mean, this computer that I use for the DraftScience channel just doesn't have a good video card, and it's an unexpandable computer. It doesn't have any expansion slots at all. So, it's very efficient, but it's basically a big laptop, without a screen. So I can't improve it any, and it just doesn't have the graphics hardware to do what I'm trying to do. So sorry about the less than perfect technical quality.